Hi everyone, today we're going to be jumping to lesson 6.8, which is going to be estimating decimal products. Okay, and if you remember that the word product in math means the answer to a multiplication problem. So if we were to look at this, we would say estimating decimal multiplication answers. Okay, and there I am giving you a thumbs up because you're going to do great. So the goal here is to use estimation and number sense to predict the relative size of a decimal. Let's look at a math message really quickly. We're just going to review some things and see, get your brain a little bit ready. Okay? So you know that 2.4 times 1 is going to be 2.4. Okay? Because any number times 1 is always going to be that original number. So here's my question. Will 2.4 times 1.8 be greater than 2.4 or less than 2.4? So let's look at this right here. Okay, I'm going to use my little pointer, I think, today. All right, so 2.4 times 1 is 2.4. Will 2.4 times 1.8 be bigger than 2.4 or smaller? What do you think? The answer is greater than. And this is why. 1.8 is greater than 1. So it makes sense that multiplying a number by 1.8 will make the answer or the product bigger, okay? Obviously, if I multiply by a bigger number, my answer is going to be bigger. Let's try another one. Would 2.4 times 0.6 be greater than 2.4 or less than 2.4? Let's take a look. We know that 0.6 is less than 1, right? Because this is just a decimal. It's a part of a number right here. We don't have anything in our ones column. We only have a 6 in our tenths. So since this is less than 1, our answer would have to be less than 2.4, right? Because if we did 2.4 times 1, we'll get 2.4. But if we do 2.4 times less than 1, well, that answer is going to be less than 2.4. This will all make sense in a little bit. Let's go over some rules to think about when working with the size of a product or answer compared to the size of its factors. So here's a little refresher, okay? This part of a multiplication problem is called a factor. That's your multiplication sign. You've got another factor, your equal sign, and then your answer. And your answer is called the product, okay? Factor, factor, product. I'm going to go over some rules. These are not anything that you need to memorize. This is not anything you're going to be tested on right now. But I want you just to be aware of this, and I want you to understand this a little bit further. So, if the second factor, which is this one, okay, is less than 1, the product will be smaller than the first factor. So let's dissect that a little bit. If the second factor, 1.8, is less than 1, is 1.8 less than 1? No, it is not. Okay? But if it was less than 1, then this answer would be bigger than 2.4, which it is not. Okay? If the second factor, that's this one again, is greater than 1, yes, it is greater than 1, huh? The product will be greater than the first factor. So let's see if the product is greater than this one. Is 4.32 bigger than 2.4? It is, yeah. So there you go. That's a rule. If the first factor, right here, is greater than 1, if the first factor is less than 1, the product will be less than the second factor. Well, this is not less than 1, so we're not going to worry about that rule. But let's check out this fourth rule. If the first factor, this one again, is greater than 1, which it is, then the product will be greater than the second factor. So here you are, okay? All right, let's get moving. So we're going to predict the size of a product. Predicting the size of a product is one way to make an estimate for multiplication problems. So we're going to work on estimating. Remember how we used easier numbers to make estimates for multiplication problems? We rounded numbers to make it easy. So 23 can be rounded to 20. 9 can be rounded to 10. 429 can be rounded to 400. This helps us solve things easier. 27 can be rounded to 30. Okay, now let's try it with decimals. So take a look. 12.8, well, that can be rounded to 10, can it? 12 itself could be rounded to 10. 185.3, we can round that to 200. 4.1 can be rounded to 4. Okay, so we can round decimals to whole numbers. 0.7 can be rounded to 1 because look, that's not a whole number, right? We don't have anything in our ones column. So this, if it's point something, 0.7, 0.63, those can all be rounded to 1. 0.9 can also be rounded to 1. Okay, so do you see how we can round decimals? Just like we round whole numbers, okay? Now let's look at those estimations to multiply decimals. So if I've got 12.8 times 185.3, oh my goodness, that's huge. Let's see if we can estimate or round these two numbers to make it easier for us. Well, 12.8 could be rounded to 10, and 185.3 can be rounded to 200. So what's 10 times 200? We know it's 2,000. And if you don't remember, 1 times 2 is 2, and count your zeros. 1, 2, 3, 1, 2, 3. You guys should know this from 4th grade too, and we did a little bit this year with that. Let's try another one. 896.1 times 2.7. Well, let's see what we can round these to. 896 could round to 900, couldn't it? And 2.7, well, that can round to 3. So 900 times 3 is 2,700 or 2,700. Watch, 9 times 3 is 27. Count your zeros. 1, 2, 1, 2. Easy peasy. 4.1 times 0.7. I bet you know this one, huh? 4.1 can round to, what do you think? Maybe 4. And 0.7, well, that can round to 1. Let's see. 4 times 1 is 4. These are our estimations, okay? All we're doing is we're rounding these decimals to make it easier to figure out what our answer could be close to. How about 0.9 times 3.3? Well, 0.9 we know could round to 1. And 3.3, well, we can round that to 3, can't we? 1 times 3 is 3. All right, now we're going to look at a little table, and we are going to use this to make some estimation number sentences. And then also, we're going to place the decimal point where it belongs. So if you look at this, they have the actual correct answers here. So 12.2 times 1.9. If you were to multiply that, like do it on a calculator, you would get all of these numbers. But the thing that's missing is the decimal point. And we're going to put that decimal point in there using our estimation. So let's take a look at the first one. 12.2 times 1.9. Well, I know that 12.2 could round to what? 10? And 1.9 could round to 2. So 10 times 2 is going to be 20. Now, if I was to put my decimal point somewhere here, that would give me a number close to 20. Would I put it here? Well, no, because that would give me 2,318. If I put it here, it would give me 231, which is not close to 20. What about if I put that decimal here? 23.18. Isn't 23.18 pretty close to 20? Yes, it is. There's that decimal there. So do you see how I used my estimation to figure out where my decimal went or goes? Let's try another one. 17.4 times 97.5. So I want to round these again, okay? 17.4. You can round them a couple different ways, but you want to make sure that you round them to the nearest whole number that's going to help you solve it, okay? So 17.4 is pretty close to 20. 97.5 is close to 100. So remember your math, doing this easier, right? 20 times 100, 2 times 1 is 2. 1, 2, 3 zeros. 1, 2, 3. So my estimation answer is going to be 2,000. Oh boy. So I want to move this decimal where it will be closer or close to the number 2,000. So if I put my decimal right here, that would not be close to 2,000. That would give me 16,965. No way. How about if I move my decimal right here? That would give me 1,696. Is that pretty close to 2,000? What do you think? I think so, right? Isn't 1,696 close to 2,000? That's how I knew where to put my decimal. Let's try another one. 83.12, okay, 83.12 times 7.25. Well, 83.12, I know I can really easily round that to 80, can I? And 7.25, well, couldn't I round that to 10? Wouldn't 80 times 10 be a lot easier than having to figure out 83.12 times 7.25? Let's see. 80 times 10 is going to give me 800. Perfect. 8 times 1 is 8. Add my 2 zeros. Boom, boom. Now let's look at this number and see where we could put our decimal. I'm going to go from this side this time. If I put my decimal right here in the front, that is going to give me less than a whole. I definitely know that 800 is a lot more than 0, right? Or less than. Let's say I move it over, 6.0262. Well, that means that my whole number is only a 6. And I know I'm looking for a whole number that's close to 800, so that would not work. What about if I move my decimal here, behind the 0? That would give me 60.262. Well, 60's getting there, but not quite as big as 800. Let's move that decimal over another spot. 602.62. 602.62. That's getting there pretty close. I think that could be a contender, but let's move our decimal over one more time just to see. 6026. Oh, okay. Well, this would give me 6,026.2. That is way too big. So I'm thinking that 602 is going to be my closest bet to 800. There we are. 602.62. Now, the number's not always going to be right there, okay, next to your estimate. But it's closer than any other choice we had. And that's where you're going to learn how to figure out where to put that decimal point. All right, now I've got 2.36 times 325.5. Oof. All right, well, there's a couple different ways I can do this, right? 2.36 can be close to 3 or it can be close to 5. Okay, and 325, well, that could be close to 300 or 400. I did it this way. I did 2.36 and I rounded that to 2 because I thought that 2.36 was closer to 2 than it was 3, and I was just trying to be pretty accurate with this. Now, 325, I rounded to 400. I could have rounded it to 300, but I rounded it to 400. The goal here is just to use your best judgment on which way to round, okay? Whether you're rounding up or down. it's not going to be that big of a deal because you'll see that your answer will still be in the place value part that you need, okay? So 2 times 400 is 800. 2 times 4 is 800. Boom, boom, 800. All right, let's go through this number and let's see where we can get a close number to 800. Where could I put this decimal that would give me a number close to 800? Well, let's start from the back this time. Definitely not. That would be 78,618. Nope. If I put it here, that would give me 7,861. Okay. If I put it here, that would give me 786. Oh, really close to 800, actually. What about if I move it here? It would give me 78. I think my decimal is going to go right here, 786.18. That would work. All right, we're going to do 2 more, and then we're going to do a little activity together, and I will show you what your classwork will look like today. 4.85. Oh, that can go anywhere, really. What do you think? Should we put it at 5 times 1.6? Maybe 5 times 2. That works for me. 5 times 2 equals 10. That's my estimation number sentence. Okay? And let's see. Oh, I've got 776 here. Where can I place my decimal that will give me a number near 10? I know if I put it here, it's going to give me a very high number, 776. If I put it here, it's going to give me 77, which is not close to 10. But if I put it right here, it's going to give me 7.76. Isn't 7.76 pretty close to 10? I think that would be our best bet. All right, and then the last one I have here is 1.8, which I'm going to round to 2, I think, times 27.3. What should we round that one to? Maybe 30, okay? 2 times 30 is going to be 60. 2 times 3 is 6. 1, 0, 60. And I have all these numbers all plopped together here, and I need to find my decimal, a place to go. Too big. Still too big. Just right. Take a look. If I put my decimal here, that's going to give me a number of 4,914. That is not anywhere near 60. If I put it here, it's going to give me a whole number of 491. Again, closer, but I think we can get even closer still. If I put my decimal here, it's going to give me 49.14. Don't you think 49 is pretty close to 60? Well, I do. That's where my decimal is going to go. Okay? So what we did was we rounded these decimals and we made them easier to solve. And based on our answers, we placed our decimal in that group of numbers. Okay? Let's try a little activity. Now, this is what your classwork is going to look like, so pay close attention. Kyle and Emma came up with different answers on their homework. For each problem, make an estimate. Write a number sentence to show how you estimated, then circle the student with the correct answer. Okay? Now, you're not going to circle it. I'll show you what you're going to do. But let's take a look. I've got 17.6 times 8.5. So right here, I'm going to put an estimation problem. Okay, so I'm going to say that 17.6 is probably closest or best if I make it at 20. Okay, so if I put 20 there times, I don't know, 8.5 close to 10, 20 times 10, how's that sound? That equals 200. Now, Kyle put his answer as 149.6. And Emma put her answer as 14.96. So if my estimation is 200, which student is closer, Kyle or Emma? If you said Kyle, you're right. Kyle's estimate or answer was 149.6. 149 is pretty close to 200. It's way closer than 14, isn't it? Let's try the next one. 65.2, okay, times 112.5. Now remember, guys, you're not actually solving these problems right now. You're just estimating, okay? So 65.2, let me think. What could it be close to? It could be 60 or it could be 70. I think I'm going to go with 70. And then 112.5. I definitely want to go to 100 because I know that it would be much easier for me to multiply something times 100 than something times 110. Okay, so I'm just trying to make this easy for myself. So let's do 70 times 100, and I know that that's going to give me 7,000. So let's see who was right here. Kyle put his answer down as 733.5. So his whole number was 733. Look at our estimation again, 7,000. Ooh, I don't know, Kyle. Yours seems a little low. Let's check out Emma's. Emma said 7,335. Don't you think that Emma's pretty close to 7,000? I think so. Emma's definitely that winner there. All right, and then our last practice one today is going to be 3.6 times 3.1. 3.6 times 3.1. Well, 3.6 I would say is pretty close to 4, right? And 3.1 is close to 3. So if I had 4 times 3, that would give me 12. Which student is closer to 12? Kyle, who has 111.6, or Emma, who has 11.16? If you said Emma, you're right. Okay, so with that, I am going to show you your classwork for today. Of course, you can continue watching this video. Go back if you need to. If you don't understand something, you can rewatch it, or of course, ask me, okay? I'm here to help you. So let me click out of this for now, and I'm going to move over to our classwork, okay? Your classwork today is going to be exactly like I just showed you with Kyle and Emma, okay? And then I'm realizing here that I didn't put my little colons next to Emma, so I messed that up a little bit. Hey, it's all right. Kyle and Emma came up with different answers on their homework. For each problem, make an estimate, write a number sentence right here to show how you estimate it, and then put an X in the blue box next to the student with the correct answer. So you're going to do exactly as I just showed you on that last slide. And if you need to rewind, go do that. You're going to look at 76.6 and you're going to round that. Maybe you're going to round it to 80. That would be good. And then you've got 8. Now, you could do 80 times 8, or you could even round this 8 to a 10, right? Maybe you wanted to do 80 times 10. Okay? You're going to tell me who's closer, Kyle or Emma, and you're going to be clicking in one of those boxes and putting an X there. So you're going to click, you're going to hit the letter X on your keyboard, and you'll be done. So you're going to write your estimation out. You're going to click whoever has the closest answer, and you're going to move on. Okay? You've got 3 problems to do, not a lot today at all. All right, I just want to make sure that you can get this understood, and that you can see how we use estimation to place decimals in decimal multiplication problems. Okay, if you've got any questions, guys, just message me on Hangout, watch my video again, whatever you need, I'm here for you. Good luck. I think that you'll find this pretty easy, but again, if you get stuck, just let me know. All right, good luck, guys.